Hey! What?
Welcome back everyone, how are you all doing? Last video was quite some time ago, but today I got something special for you. We will begin adding enemies to the game. I don't think there's much to say before we start, but if you're new to the channel, welcome. Don't forget that there's a Discord dedicated to ask questions in, and also the code can be found on GitHub or on my website. And if you enjoy this content, then don't forget to subscribe and like the video. And if you want to go further to show your support, there's a link in the description below to my Buy Me a Coffee page. Now, without any further ado, let's get into the episode. This episode will be split into a few parts. How many that will be, I am not sure yet. The goal for today, the first part, is to add the enemy and to make it animate. The second part will be focusing on adding the hitbox and making the enemy detect the level just like the player. The enemy should also be able to patrol by the end of that part. The third and possibly the last part will focus on combat. The enemy should be able to see the player and then make a decision based on that. This of course is subject to change, but it will give you a good overview on how we will structure these upcoming videos. Now, let's get coding. Alright, let's begin. Let's start the game and see how it looks currently. So we had our background and our background in game as well. And it should still work. It does. Alright, so the first we're going to do is to grab this sprite, which is the enemy we're going to work on today. It got 5 different states. We got idle, running, attacking, getting hit, and also dying. So we're just gonna grab it and drag it into our res folder and then go OK. And into our utils package, load save class, bring it up here. And we've done this a few times, so let's just copy that and paste that. Let's call it Crabby Sprite. And it's called Crabby Sprite. Alright. Alright, so the first class we're going to add is inside our entities package, and it's going to be a enemy class. So enemy and then finish. And this enemy is going to extend our entity class that we have here. So it's going to extend entity. Of course, we need to add a constructor like this. And this is going to be the main class all the enemies are using. So we're going to have 2 enemies in total. Both enemies are going to have a class for themselves, but they're going to extend the enemy class. And this enemy class needs to be an abstract class, meaning that we cannot create an enemy out of just enemy. It has to be extending the class enemy. Just like the class entity is a abstract class, so we cannot just create a entity. We have to create a player that extends entity. And that's just a way of making sure that we don't get any weird objects. So yeah, enemy needs to be a abstract class. And this enemy class will need a few variables. First, we're going to need a private int animation index for animation, and also a enemy state, meaning the enemy can be in idle, running, attacking, what have you. So we need a integer to store the current enemy state. And of course, the enemy type needs to be here as well, so we know what type the enemy is. And we also need a private int for animation tick, and animation speed equals 25. Maybe this should be a global variable somewhere, but nah, let's just leave it here. I know the player, I think the player has one as well. Yeah, animation speed equals 25, but yeah, just leave it for now, not important. And we also need to initialize our hitbox, and that code is in our entity class. So yeah, we don't have to code that at all. It's already coded for us. We also need to take in a new integer, which will be the enemy type, which we're going to say this enemy is the type of one or the other. So we're just going to add a simple setter, this dot enemy type equals enemy type. Simple as that. Then of course we need a private void update animation tick, just like the player. And we've done this a few times, so it should go pretty fast. Animation tick plus plus if animation tick is more or equal than animation speed. Animation tick equals 0. Animation index plus plus if animation index is more than or equal to get sprite amount, but we don't have that coded yet, so we're gonna leave it for now and just say 9,999. And we're gonna get to that later because we're gonna need a getter inside our constant class, but we don't have it yet. We're gonna get to that soon. And it's gonna do the same as the player, so if we are more or equal to the amount of sprites in this animation, then we need to say animation index is equal to 0. Simple as that. Then we need a public void update, so we can update this enemy. And for now we don't have much to update, but we do need to update the animation. And before we complete this class, we need two getters. We need a public int get animation index, which is going to return the current index for this enemy. And that's because we're not going to draw the enemy inside our enemy class or our, well, in this case, our crab class. We're going to do that in a enemy handler. For now, we just need to return it. Animation index. And then, of course, we need a public int get enemy state. Return enemy state, like that. And that's all for our enemy class for now. We're of course going to change this in our update animation tick, but I don't want any errors for now, so we're just gonna leave it as is. Before we add the crab class, let's head over to our constant class and add the constant values that we are going to need for our enemies. So we will need a new class in here. So we're going to add a public static class enemy constants. First, we're going to set a public static final int, and we're going to call it Crabby. So we need a constant value for saying that this is the crab, or Crabby in this case. And then we can get over to setting the different enemy states. So public static final int idle equals 0. And let's copy this 5 times. 2, 3, 4, and 5. We have idle, we have running, we have attack, we have hit, and then we have dead. So idle, 1, 2, 3, and 4. So idle, running, attack, hit, and dead. 0, 1, 2, 3, 4. And then of course we need the size of the actual sprite. So public static final int Crabby with default is equal to 72. You can copy this final int. Crabby height default is equal to 32. And then actual size will be Crabby width is equal to, recast over to int, Crabby with default times game.scale. And for height, Crabby height is equal to, recast over to int, Crabby height default times game.scale. Alright, so now we have the default size and also the actual size in the game. And inside our enemy class we had this 9,999. Let's just add the actual function we need to replace it. So it will be a public static int get sprite amount. Just like the player one, but this one will be focusing on the actual enemy. And we're gonna need two types here. We're gonna need an int enemy type, and then of course int enemy state, because each state will have a different amount of animations, just like the player. And we're gonna first switch for enemy type, because we're gonna have different types, so we start depending on which enemy it is. And in here we're going to add a case for Crabby. If we are in Crabby, then we add a switch enemy state. So we have a switch inside a switch. And depending on what type of enemy states, we're gonna have different amounts of animations. Case idle, we're gonna return 9. Case running, we're gonna return 6. Case attack, return 7. Case hit, return 4. And case dead, return 5. And that's all for our Crabby, but we still have a error here. At the bottom of this outer switch, we're gonna add a return 0, just to get rid of that error message. So I think that's all we need inside here for now. Let's head over to our enemy class, and at the top, import static util dot constants, enemy constants, and let's just grab them all. So instead of 9,999, we say get sprite amount. So enemy type, and then of course enemy state. And now it looks much better. And now I think it's time to add our actual enemy. So inside our entities package, we add the Crabby enemy. And Crabby will extend enemy. So we're gonna have an error right away. We need to create this constructor, and we can remove that. And if we take a look at what Crabby is asking for here in its parameters, it's asking for a x, y with height enemy type. It's only the x and y that will be different from each Crabby if we're gonna spawn them. The width and height we already have constants for inside our constant class. And the enemy type, well, we know it's a Crabby, so why would we need to say it's a enemy type crab when we already know it's a crab? So we're gonna remove these last 3. And for our enemy type, we're gonna add Crabby. And of course, we need to import that static. Import static utils.constants.enemy constant dot. We will most likely need more constant values, but for now, let's just import the one called Crabby. You know what? Let's just grab them all. And that's because we need to set width and height here. And we're gonna say Crabby width and Crabby height. So now we only need the x and y, and our Crabby width and Crabby height is taken from constant as well as the enemy type. And that's all we need for our Crabby class for now. We have only pretty much 2 goals for this episode. It's to see the enemy in the game and also make sure that they are animating. So nothing specific for Crabby is needed inside this class to be added in this episode. So our Crabby class is done for now. So right now we have the Crabby class that extends the enemy class. But we're not just gonna add a Crabby inside our playing class, like here's a Crabby, do something with it. We're going to add a enemy manager. So inside our entities class or entities package, we add a new class called enemy manager. So the enemy manager is going to have a similar role as the level manager have with levels. So it's going to do all the code necessary for the enemies to work and patrol and attack and all of that inside this class. And then we add this class in our playing class and just update the enemy manager. So we have just the code for enemies inside our enemy manager. And this enemy manager, we're gonna start by adding a constructor. So public enemy manager. And it will take in a playing, because I think we're going to need to go back and forth to our playing class. And we're going to add that up here as well. Private playing. This dot playing equals playing. And also need to import that one. First, we're gonna create a method that loads the images. So load enemy images. And we're going to create that one. And in here, we're gonna load the images, but we have no buffered image array. So let's add that. Private buffered image array. And we're gonna call it Crabby array. And we need to import that buffered image, and Crabby array will be equal to new buffered image, and it's going to be, and the size will be 5 and 9. So it's 5 different types of enemy states, and the max of them will be 9 indexes. And it's not buffered image, it's buffered image. And then of course we need to get the actual temporary image where the crabs are, which is in a buffered image temp equals load save.get sprite atlas load save.crabby sprite. So let's just quickly add a nested for loop int j equals 0, j is less than crabby r dot length j plus plus for int I equals 0, I is less than crabby r j dot length I plus plus crabby r equals temp dot get sub image, and it's going to be I times crabby, and we need the actual constant values. Import static utils dot constant enemy constants, and let's just grab them all. So I times crabby with default, j times crabby height, and for width we go crabby with default, and for height we go crabby height default. So that should be okay. And why is there an error? Oh, maybe we should decide where it should be as well. My bad. So j I. That looks better. And this enemy manager will have an update, of course, so public void update. And it will have the draw method. Public void draw graphics g, and then like so. And of course we need to import graphics like that. Now we also need to store our crabs in an array. Not the images, but the actual enemies. So instead of having just one enemy, we will add something called private array list, and it will be of the type Crabby. And we're gonna call this Crabbies equals new array list, and like so. So now when we have the Crabbies array list, we want to update all our crabs. So all we do is go to our update for Crabby C, and we're gonna use the Crabbies array and say c.update. Simple as that. And in our draw method, we're actually going to make a method inside here, draw crabs. And we're gonna put G in there, and then we're gonna create it, because we're gonna have another enemy here and I don't want it to look so messy. And for each of our crabs, we're gonna say g.drawImage. I'm gonna use this one. The image will be Crabby array, and we're gonna go like so. First we need c.get enemy state, then we need c.get animation index, and for x we're gonna go c.get hitbox.x, but it's a float, so we need to recast this over to a integer. And for our y, we're going to do the same, but we need to recast that over to an integer as well. So int c.get hitbox.y. And we're actually going to use Crabby width and Crabby height. That's good, and null. And that's all we need for our draw method when it comes to our crabs. Right now we have no enemies in the game and we have no way of adding them. Well, we could add them manually, of course, it would work, but it would be a terrible idea because each level will have a different amount of enemies and different positions. So we're going to use our level data, the image that determines how our level is going to look. Oh, that's a tiny image. And currently we're using the red color of a pixel to say this tile I want here. But now we're going to go to the next color, the green color, and say here we're gonna have an enemy. So into our load and save class, and right above our get level data here, we're gonna add a public static array list. It's gonna return an array list of Crabby, and we're gonna call it get crabs. And we need to import array list and also Crabby here. And we're gonna do something very similar to this one. So let's copy that and say buffered image, temporary, right? And then array list Crabby. So we need to store each crab we find in a list is equal to new array list. Like so. And then of course we need to loop through the array, so let's just actually copy this. But instead of color get red, we're gonna say color dot get green. And if the value is equal to Crabby, meaning 0, we maybe need to import that and say import static utils dot constants dot enemy dot Crabby. We don't need all of them, we just need a Crabby constant. So if the value is equal to Crabby, then we don't say value equals 0 or level data. We say list dot add new Crabby. And we need an x and a y, so we're gonna say I times game dot tile size, and then of course j times game dot tile size, like so. And we end it by saying return list. So we go over the image, and if we find a color with its green value equal Crabby, in this case 0, then we add a Crabby at that position to the list, and then we return the list. So in our enemy manager, we add a method that calls this. And we're gonna call it add enemies. And it's going to do exactly that. So our Crabbies is equal to load save dot get crabs. It's not more difficult than that. And that's all we need to do to get the crabs from our level data image. And now our final part to get this all to work is to head over to our playing class, and underneath our level manager we can add a private enemy manager like so. and we need to import it. And where we initialize the classes right here, we have level manager. So we say enemy manager equals new enemy manager and this, because we are asking for a playing class and not the game class. And in our update method, right after player update, we say enemy manager dot update. And for our draw method, after the player, we say dot draw. And of course, we need to use the X level offset. So let's just get that right away. X level offset into our enemy manager, where we say draw, then we say int X level offset. And for our draw crabs, we also pass it along X level offset int X level offset. And for our X, we say minus X level offset. So we get that right away. And I think it's time to test it. But before we do that, inside our enemy manager, we're just gonna add a sudo and say size of crabs equals, or size of crabs plus crabbies.size. So we get the size of this array, meaning we know how many crabs are in the game. And I think we need to edit our level file, but let's give it a try right away without that. And we got an error right away saying you can't close it because it's null. Oh, we didn't add .png. That's gonna cause an error, of course. So we have Crabby_Sprite.png. If it didn't have the PNG, it couldn't find the image. So how about now? All right. So if we start it, or rather check the log, so size of crabs is 0, so we actually need to edit the level file to get some crabs in our game. So let's do that. So if we zoom in here and take a look of our color values right here, 11, 234. Yeah, we have no zeros anywhere here. So let's grab this color right here, change the pencil, change the value of green without changing any other value, and then just get a enemy right there, an enemy right there, and let's add one right there. Overwrite our current level data, and then try it again. But first we need to refresh it, and let's see if we have some enemies now. I think we do. All right, we got 4 crabs in our game. They are animating, they're in the idle state. There is, of course, some distance between the enemy and the ground, but that's because we haven't worked anything on our hitbox for them. So this is just get the enemies in and get them animated. And we completed that task for today. And if you got this far, good job. Alright, this is a good start. We got our enemy in our game. It's also animating, which is good. So this will be our stop for today. I hope that you enjoyed this episode, and if you did, don't forget to subscribe so you don't miss the next part of this topic. Until the next episode, take care now and have a wonderful day. Bye.